Hey guys, today we're looking at 4.4, which is the graphs of the secant and cosecant function. We've talked about sine and cosine, we've talked about tangent and cotangent, and now it's time for secant and cosecant. The secant and cosecant are reciprocals of the sine and cosine functions, so you can see that the graphs kind of look like they're the opposite of the sine and cosine waves. You can see that the ranges are the exact opposite. While sine and cosine was between -1 and 1, now we have that our range is everything outside of -1 and 1. So our range goes from negative infinity to -1 and from 1 to infinity. So our range is everything outside of that. If you kind of look at the graph, you could see how your wave could fit in between the secant and cosecant graphs here. So you can see how it's literally the reciprocal opposite of our sine and cosine waves. Secant, we have asymptotes that are of the form 2n plus 1 times pi over 2, or you could look at that as pi over 2 plus n pi. So we do once again have a discontinuous function. Because we are outside of -1 and 1, everything less than -1 or everything greater than 1, we do not have any x-intercepts. And also they're reciprocals of sine and cosine, so we are back to having a period that matches with those, so our period is 2 pi. We're not looking at a wave, so we don't have an amplitude. There's no minimum or maximum values here, but that a value that did determine our amplitude for our sine and cosine is still going to be helpful here. You can see that we hit at 1 and -1 when we're talking about these kind of U-shape parts of our graph, and so that a can tell us if we have a stretch or a shrink. So it's still going to be helpful. We're just not going to call it an amplitude. And then this graph is symmetric with respect to the y-axis, so it's an even function. So the secant of -x is equal to the secant of x. Now, the secant is the reciprocal for cosine, and cosine was our other even function, so that kind of makes sense that the two reciprocals of each other are the two that are even functions, are only two even functions, actually. If I look at my secant function, you can kind of tell that at the x equals 0, we have a point 0, 1. And then when we come down to our cosecant function, at x equals 0, we have an asymptote instead. So that's kind of a nice way to help tell them apart. It would also help if I could spell asymptote. There we go, forgot a T. You can't really see it here because it's right on the axis, but you do have an asymptote going up and down there. When we're looking at our cosecant function, our asymptotes are x equals n pi, or pi n, however you look at it, pi n, n pi. So x does not equal n pi is the domain, where n is an integer. And then if you're looking for the actual equation of the asymptote, it's x equals, instead it does not equal. Our range is the same, everything less than -1 or greater than 1, so the same as the secant function. Also, just like the secant function, there are no x-intercepts. We're back to a period of 2 pi. So sine, cosine, secant, and cosecant all have a period of 2 pi, but tangent and cotangent are the ones that have the period of pi. We don't have an amplitude, but you can see we're hitting at +1s and -1s for all of our U shapes. So that A value will help see if we have a stretch or a shrink. And this graph is symmetric with respect to the origin, so it's an odd function. So the cosecant of -x is equal to the negative cosecant of x. So let's actually graph a couple of these and see what's going on here. When we're graphing these, we are going to go ahead and start at 0 just to kind of make it easier to match with what we've been doing for all of our functions except for the tangent one. So I'm going to make my table over here, and I'm going to put 0 at the very beginning of it. And I need spots after that for my 4 pieces and then my period. So make your table, and then we need to actually find that period. So remember, it's your current period divided by b. So since we're talking about secant and cosecant, that's going to be 2 pi over b. Our b value is whatever's right in front of our x. So in example 1, our b value is 1/2. I can't leave it like that though, so I'm going to multiply top and bottom by 2. On the top, that gets me 4 pi. On the bottom, the 1/2 and 2, the denominator in that 1/2 with that 2 cancels, and I get 1. So 4 pi over 1 is just 4 pi. So that's my period, and it's going to go on the end of my interval, 4 pi. Then to find the parts that are inside my interval, I need to find exactly what's in the middle. So I'm going to do half of my period. Well, half of 4 pi is 2 pi, so that goes right in the middle. And then I need to find a fourth and 3/4. So 1/4 of, oh, that's supposed to be 4 pi, not 2 pi. So 1/4 of 4 pi is pi, and 3/4 of 4 pi is 3 pi. So this one's kind of nice and easy. Pi, 2 pi, 3 pi, 4 pi. Now, when we're talking about a secant function, remember when x is 0, we have a point 0, 1. So that means right here I would have a 1. Then the next part would be an asymptote, so my y value would be undefined. Then I'd have the u part that goes down, so I'd have a -1 at that 2 pi. I'd have another asymptote, so an undefined y value. And then I'd have another u going up, so a +1. So you can kind of see that up here. We've got the u going up, the asymptote, the u going down, the asymptote, and the u going up. So when we talk about our period, we're just starting here and only doing half of that U shape. Asymptote, U shape, the full U shape down here, asymptote, and then half of the U shape. So ours is going to look a little interesting because we're going to do like half of parabolas or half of U shapes. Not quite exactly parabolas. So when we're talking about our asymptotes, no matter if I have a value or a reflection, if that a value is negative, or if I'm moving up or down, those will always stay undefined because they're asymptotes. And an easy way to find the equation for your asymptotes here is that x is going to equal 1/4 of your period plus half of your period times n. So if I'm looking for a fourth of my period, well, I just found that to try and fill in my table. A fourth of my period was pi. So x is going to equal pi plus, and then I also had to find half of my period to fill in my table. Half of my period was 2 pi, and that's the part that I multiply by the n. So there's the equation for any asymptote in my domain. I would just put an integer in for n. So I could plug 1 in for n, or 2, or 3, or 4, or 5, or -1, -2, -3, -4, and -5. Now your a value, or a shift up or down, is what's going to change the ones and the negative ones. So we do have an a value here of 2, which means that we have a stretch by 2. So what that means is that I'm going to take all of these and multiply them by 2. So instead of at 0 hitting at 1, my y value is now going to be 2. When x is 2 pi, instead of hitting at -1, now I'm going to hit at -2. And at 4 pi, instead of hitting at 1, now I'm going to hit at +2. And now I've got everything I need to be able to draw my graph. So let's go ahead and draw it. So I've got pi, 2 pi, 3 pi, and 4 pi. I'm going to go ahead and put my asymptotes going up and down at pi and up and down at 3 pi And then I'm hitting up at 2 and down at -2. So I'm going to start here and have half of that U shape. Down here, I'm going to have the whole U shape. And up here, I'm going to finish with half of that U shape. And there is my secant graph over one period. Let's look at a cosecant graph. So I'm still going to start my table at 0. And I'm still going to start by finding my period. So 2 pi over b. Notice for this one, b is just equal to 1. So if I have 2 pi over 1, my period is still just 2 pi. So it's my original period of 2 pi. I still need to fill in those other parts of the table so I can still do what we've done. I can figure out what 1/4, 1/2, and 3/4 of it is. So if I'm looking exactly halfway in between, well, half of 2 pi is just pi. So exactly halfway in between is pi. The fourth of 2 pi would be pi over 2, and 3/4 of 2 pi is 3 pi over 2. So I filled in all of those x values. Now I got to start looking at the y values. So when I'm looking at a cosecant graph, when x is equal to 0, I've got an asymptote instead of a point. So that means I'm going to start with my undefined value, go up to the 1, have another undefined value for the asymptote, go down to the -1, and then I have another undefined value for my asymptote. So you can kind of see that here with my cosecant. I've got the asymptote, then the 1 that matches with that U shape, an asymptote, the 1 that matches with that U shape, or sorry, -1 because it's down, matches with that U shape, and then we end on another asymptote. Now I just need to see if something is going to change those 1s and -1s, and I need to find the equation for my asymptotes. So let's start with the equation for the asymptotes. For this one, for cosecant, the equation for my asymptotes is going to be that x is equal to half of my period times n. And lucky for us, we did find half of the period. So I'm going to have x is equal to, well, half of my period was pi times n, which this is our original period. So that should match with what we have up here, and it does, in pi n. And then for my y values, the 1 and the -1, I do have an a value that's going to adjust that. Now, for both of these examples, we did not have a reflection and we did not have a shift up or down, but that doesn't mean it can't happen. You can have a reflection, a shift up or down, or an a value that is a stretch or a shrink for any 6 of the trig functions: sine, cosine, tangent, cotangent, secant, or cosecant. For this one, though, we do just have a stretch by 3/2. So with this stretch, I'm going to take all of my y values, which in this case is just the 1 and the -1, and I'm going to multiply them by 3/2. So 3/2 times 1 is 3/2. 3/2 times -1 is -3/2. And let's draw our graph. So pi over 2, pi, 3 pi over 2, 2 pi. Sometimes it's kind of hard to draw an asymptote going up and down on the axis, so I draw it off just a little bit so you can see that it's there. Then I've got one going up and down at pi, and one going up and down at 2 pi. And then I'm going to do my tick marks by halves. So there's 1, and there's 2, -1, and -2. We go up to our 3/2 and down to our -3/2. So when you're looking at these, one full period involves two of the U shapes. They could be split in half, like our example one was, where we've got half and then a full one and then the other half. Or it could be like example two, where we've got a full one and then a full one. So when we're looking at problems like three, where we have to write our equation based off of the graph, you need to make sure that you're being careful when you're trying to figure out what your period is, that you're looking for two full U-shaped parts of the graph to make a full period. So keeping that in mind, let's go ahead and look at example three. We need to figure out first if it's a secant or cosecant, and then we have four different things that we've got to kind of check off to see how it affects our equation. So if I'm looking at example three, the first thing I'm going to notice is what is happening at zero. I can see that there's an asymptote going up and down when x is zero. So that's going to tell me that this is a cosecant. Remember, you can have horizontal translations left and right, but we're not going to talk about those for our class. So looking at zero and what's happening at zero when x is zero is going to be the best way for you to be able to tell what type of graph you're looking at. So the four things that we need to check off is there a reflection? Did we shift up or down? Was there a stretch or a shrink? And did the period change? So if I'm looking at this one, is there a reflection? Well, if you look at both our cosecant and our secant functions, you can see that our first parabola U-shaped graph starts up. So if you're looking at zero, the first part after zero needs to be going up. If it's not going up, then we have a reflection. So if I come down here, I can see that the first part is indeed going up. So is there a reflection? No. Now, did we go up or down? To figure that out, we need to look at the center line. So normally the center of the graph is on the x-axis. It's centered around that x-axis. Now, if we're looking at this, you can see that the graph is still centered around that x-axis, so we have not gone up or down. There is no shift up or down. What would change is if you can kind of see that the U-shapes, instead of being centered around the x-axis, have kind of all shifted up together or all shifted down together. Next is a stretch or a shrink. Normally from that center line, you should be going up one or down one, depending on if the U is up or if the U is down. So you can see that we are going up one and down one. So is there a stretch or shrink? No. And then the last thing that we need to check is the period. Has the period changed? This one's kind of easy to tell because we are starting at zero and going to 4 pi to get our two U-shapes in. So our period here is 4 pi, and that is not our normal period. So our period has changed. So this is where I do the 2 pi over b has to equal that new period. So you can multiply both sides by b. So you get 2 pi is equal to 4 pi b. And then I'm going to divide both sides by 4 pi. And the pi's cancel and I get 2 over 4, which simplifies to 1/2. So that needs to go in my equation right in front of my x. But since we don't have any other transformations, there's nothing else that's going to go in my equation. So that's it. It's just y equals the cosecant of 1/2 x. Okay, so now I'm going to kind of repeat the process over here with my other graph. First thing is what is happening at x equals 0 to figure out what type of graph it is. If I'm looking at x equals 0, I've got a point, which means we're looking at a secant graph, as opposed to having a asymptote, which would make it a cosecant graph. You can also see the first part here is going up, so there is no reflection. And normally we should be centered here at the axis, but you can see that we're kind of centered up a little bit. We're centered here at 1, so we did move up 1, which means I'm going to have 1 plus in front of my graph. So do you kind of see the difference I'm talking about? If you move up or down, you can kind of see how the graph is centered at a different spot. Then from that center line, you can see that my U shape is still up one and down one, so there's no stretch or shrink from that new center line. Sometimes they could be up more or down more, and that would tell you if it's a stretch or a shrink. So last thing I need to check is the period. And this is where this one's a little bit different. We're not starting our period at 0. You can see they're starting over here at negative pi over 2 and going to 3 pi over 2 to get the full 2 U shapes, one up here and one down here. So to find that, I know I'm going pi over 2 this way, and I'm going 3 pi over 2 this way, so I'm just going to add them together. That gets me 4 pi over 2, which is 2 pi. So my period is 2 pi. That is my normal period for a sine, cosine, secant, and cosecant graph. So I don't have a b value. All I have is that shift up, and there's my equation. And that's it. Let me know if you have any questions. Make sure you get started on your assignment that goes with this set of notes, and you all have a good day.